So many of us are at least casually following the rover Perseverance that NASA just landed on Mars last week. But what you might not realize is that a company from right here in our neck of the woods was involved in the process that made that rover a reality in the first place. So joining us this morning for Tech Belt today is Laura from the Barnes Global Advisors. Laura, thank you so much for joining us. I'm so excited about this segment.
I am too.
Very cool.
Thank you for having me on.
Oh, we're glad to do it. So the company is based in Pittsburgh, but works with America Makes, so we have that local tie-in for us here. But I want to know, in the first place, how did your company even get involved with this project?
Yeah, we initially started our relationship with NASA Jet Propulsion Laboratory, who are the group that built the Perseverance rover, and we're delivering custom additive manufacturing training for them, for their staff, to enable the next generation of additive parts in space. And the really cool part is that this gave us this amazing opportunity to see the Perseverance rover in person during acceptance testing in December of 2019. So when you talk about those mind-blowing moments, I realized that I had stood about 25 feet away from a vehicle that is now traversing the surface of Mars.
It is wild to even think about, and it's got to be very cool for you. But just in general, how important was 3D printing then in making this rover a reality?
Yeah, absolutely. So anything that goes to space, it's all about maximizing the payload. And the payload is the stuff that you shoot into outer space on a rocket. And more recently, there's also been a bigger focus on reducing cost. So due to the layer-by-layer nature of the process, additive manufacturing can build parts that are just not possible by traditional manufacturing like machining. So you can use the process to reduce mass, optimize performance, reduce costs, combine parts. So in other words, you get to take more cool stuff to space. So in the case of Perseverance, they are taking instruments to perform experiments and collect data. So of course, conserving mass and getting more things onto the spacecraft means more experiments that they can do. So they did 11 metal 3D printed parts using laser powder bed fusion. One was on an instrument called Pixel, and one was on an instrument called Moxie. And with each of those, they were maximizing either heat exchange or space so that they could do more experiments up on Mars.
It's incredible, and I feel like a lot of people, even now, when they think of 3D printing, they think of like the filament or something that they would not even imagine holding up to the rigors of space. So do you think that that's part of this too, in terms of people understanding how truly heavy-duty and industrial these can be?
Absolutely. I mean, NASA has always been one that's paving the way with respect to technological advances and showing the art of the possible. So in this case, these are, metal parts. These are high rigor. These are technically secondary structure, which means if they fail, the entire mission will not fail. But what it does is it paves the way for that next generation of parts as well. So they're going to do great things on this mission, but it also lets everyone see that these parts can be used in space and can be used in many other applications down here on Earth as well.
Anytime you're talking about space exploration, I think it gets a wide range of people excited, regardless of what the topic is. So what do you think that people seeing that 3D printing is involved in something like this can do for the industry going forward and for the next generation that maybe isn't even considering it yet?
Yeah, absolutely. I see additive manufacturing as being this just huge recruitment tool for manufacturing and for the younger generation just to get excited about STEM in general. I have 2 young kids, and we've built, Lego rovers and space shuttles, and we're all excited about it. And manufacturing, doesn't have to be dark and dingy. It can be exciting, and we can shoot things into space. And we need to build that future pipeline of bright minds that drive interplanetary exploration, as well as making life here on Earth better, faster, and cheaper. And additive manufacturing has the opportunity to do all of those things.
Absolutely. So, Laura, thank you so much for taking some time out and talking to us about this. It's exciting. It's got to be even more exciting for you because you saw it on the ground here on Earth before it even launched. So thanks again for joining us this morning. We appreciate it.
Yeah, thank you.
All right. That was so cool. Man, every time we look at any of those pictures now, we know that a company from around here had something behind it. That's really